Okay, let's try number 2. Same sort of thing. You have the table, you have the prices, you have the number outstanding, and I've done the calculations for you, right? So these are the total values of outstanding stock. So this is S. This is the total value of outstanding debt. This is B. And then this total, the sum, is V, the value of the firm. These are the weights. Well, this one is S plus B, S over S plus B, but this one is um, B over S plus B. Anyway, they have to add to 1 is the point. So let me put that up on my iPad. So just work on it. I'm going to start doing it. And you can check, verify as I go along. Oh, I did the wrong. No, I want to share with you my iPad. Okay. RF is 4%, and the expected return on the market portfolio is 15%. So that's basically RF, that's ERM. Be careful that sometimes I give you the market risk premium, so make sure you read carefully. Canvas equity has a beta of 1.2, so that's going to get us to the RS. And then this is all about the bond. So it's the same problem, just a different corporate tax rate, some different values. Do we have the price of the bond? Yes. So let's do everything again that we just did. So what we want to solve is WACC equals RS times S over S plus B plus RB 1 minus TC B over S plus B. Now these are all calculated here. This one is S over S plus B, and this one is B over S plus B. This one is V, or the S plus B. So you have all the values given. So for RS, we're going to find our S from the capital asset pricing model of 0.04 plus, right? So this is R RF plus beta RF. I'm trying to stay with the lowercase. No, not ERM minus RF. So beta was given as 1.2. And what is the market risk premium? 15 minus 4 is 11.
11.
So RS is
17.2%.
and this is as an assumption of the capital asset pricing model assumptions holding. We had to do that to get that result. So then, what else do we need? We have all of these. We need RB and 1 minus TC. Oh, 1 minus TC, TC is given as 45%.
55% is 1 minus TC.
Right, and 55% is 1 minus TC. So let's get RB. So let's use the information given for RB. So what did we learn? We learned that we have to use the formula Okay, so what do we know? What is the coupon? Annual coupon rate. Aha. So you got to read it carefully. The stated annual coupon rate, but it's okay. So we got to be sure. Coupons are paid semi-annually. Aha. So this is tricky, right? We have to divide by 2. Even though it says annual, it's stated annual. In other words, this is just the simple interest equivalent. In fact, semi-annually, we know the payments are made as C divided by 2 times 1,000, which would be 0.13 divided by 2 times 1,000, which is how much? $65? Is that right? Are you guys going to agree?
I
So that's $65 per semi-annual period. How many semi-annual periods are there? Six years or 12 semi-annual periods. So I have so far, I have this and I have this. And so what's the face value? 1,000. And what's the price? 975. So put it all together and get EPR 1/2. So let's put it all together. So 975 equals 65 over I 1 over 1 minus 1 over 1 point. Oh no, 1 plus I, because I don't know what it is. I'm trying to find it. And then this is 12. And then this is 1,000. So you have to write this out to get the points. 1 plus I to the 12. And then find I equals. So you're going to put N into N is going to be 12. Into I is what we want. Into PV is 975 negative. Don't forget. Into payment is 65 to be received. And then also to be received is the $1,000. Positive. Payments are positive. Sorry, FV. What's happening here? You can't seem to clean that up.
It gives me 6.8116 and others.
Is that what everybody else is getting? No. Yeah, that's right. So that's EPR 1/2, and then you convert it. You need the effective annual version for the formula of WACC, okay? So RB, you have to know what that means. It's effective annual. So we have to take 1 plus EPR 1/2 square minus 1 gives us EAR. So EAR is equal to RB. What do you get? Make sure as you're going along, you're storing your results, like this one. If they have decimals. I didn't store RS because it had no long decimal stream. And whatever I get here, I'm going to put store 2. So when you put that together,
60.02 others.
no, you did something wrong. Remember to put the zeros on it, eh? I don't know what you did.
We put it in decimals. Or
Just don't make a mistake. That's all. You have to, if it's decimals percent, just don't make a mistake. You made a mistake somehow. Did you get it? Okay, so we have to put in 12 into N, 975 negative into PV, 65 into PMT, and 1000 into FV, and then compute the interest rate. So then you have to be careful, divide it by 2, divide it by 100, I mean, and store that in 1. Now that you've stored it, now we're going to convert it. You're going to add 1, and you're going to put it to the power 2 minus 1. No, what did I do wrong? No, I have to do the other way around, right? I did it wrong. I had the wrong formula, I just realized. Okay, because this was, no, I don't. This is a semi-annual. We have to square it, minus 1. That should be right. Let me check. What did I do wrong here? Oh, I see. Yeah, that's fine. That's right. That's right. So recall 1 plus 1 power 2 minus 1, and that is the effective annual rate. But then you want to multiply it by 1 minus TC. So anyway, let's write that down. Let's store 2. So that's going to be the effective annual rate. And then we're going to put it in here now. So I often do the 1 minus TC in the notes, so let's put that there so you can see the same numbers. So we want this 1 minus TC, so 1 minus 0.45 is like Alvaro said, 0.455 times RB. What is that? That's going to be 0.55 times this times 0.55. Oh, no, that's not right. Recall 2, is it 0.55?
0774.
That's it. Store 3. My goodness. Recall 2 times 0.45. Sorry. Recall 2 times recall 2, recall 3. Oh my goodness, I messed up my thing. Recall 1. That is plus 1 to the power 2 minus 1. and then times 0.55. Yeah, store 3. Okay. So store 2, that's store 3, which is 77480. Yeah, or 774. I'll just put all the decimals, it's easier. So are you guys good? Something clicking there? 0.077479509 dot dot dot. So then that is this here, store 3. And so you're going to put together RS, which was 0.172. The bracket, now I have the rounded values here, as long as, we'll just use the ones there. I think maybe I did that. Yeah, I just use the numbers there. If you kept all the decimal places, it will be a little different, but not immediately for the decimal places. It will be in later decimal places. So this is going to be 0.433881. Okay, I'm just looking because it goes step by step. A, B, C, D. I use just the whack. I just did the final answer and I wrote it backwards. So maybe it's confusing. Maybe it is confusing because I have it written differently in the solution. So this is basically what you're doing. So RB is going to be this number here, 0.07747 dot dot dot. Just use recall 3. And then with that weight, 0.566119. Now on the exam, I'm not going to make these long decimal things. Like it's going to be pretty basic. I'm just getting you to practice, and become proficient, but I'm not going to make it too messy. Shouldn't be too messy. So when you put it all together, you should get that the WACC is 11.849. So this one is 17.2% for equity. The after-tax cost of debt is it's smaller. Usually it's smaller. So it's 7.74%. And then because it's a weighted average, you end up somewhere in between. So the WACC is close to what we usually use as the return to market portfolio of almost 12% there. So it's 11.849. Now there's a bunch of other questions. So I answered E, but we have also, so I did the expected return to equity is our S, which we calculated over here. So this is A. After tax cost of debt, we did that over here, which is B. I should probably use a different color. I think we're out of time though. C, the beta, then I asked you for the beta of after tax debt. So what you're going to do is get this, use this value to get the beta using capital asset pricing model. So this can be used for C. Or you can compute C, let's say compute C. And then for beta of assets, okay, so what you can do then is you use the beta of debt after tax and the beta of assets, which is given over here, and make a weighted average to find the beta of assets for CanWest. So you have all the information. We've already calculated everything. You just have to learn how to answer the question. So I'm going to stop because the other group is going to come. Actually, you can ask me your questions. They're going to be, we have some time. If you have time to answer your questions.
Which one was D?
And D is going to be beta of equity, beta of debt, and you have to make a weighted average to get this. It's in the solutions, but that's basically um, the beta of assets. So that is on the security market line. This is the return to assets, and this is the beta of assets. So they have the relationship of the capital asset pricing model between them. So we already have the WACC, so you can do it two ways. Either you can do the weighted beta, which is in the solutions. Just do the weighted beta. Weighted beta means beta S with this weight, and then beta V with this weight. And that will give you the beta of assets. How do I get the beta of B? That's the question that remains. I get the beta of B by, let me see, make sure I have it here. Using the capital asset pricing model. Yeah, you have to just isolate. Um, so basically it's risk and return, risk and return. So if you have the risk, you can get the measure of risk, you can get the return using the CAPM, but also the other way around. If I have the return, then I can use the capital asset pricing model to get the risk. That's what you got to do there. So why don't you guys try that? Keep me posted if you can get the answers. But that's all this is. It's just repeated problems like that. Do them all. And then I have a graph here where you can visualize all of it. So I'll just show you that before you go. And I'll post the solution. I separated it from the others and I think it's important. So here it is. So we have given the RS, given the beta of S, we got RS. We can plot RF. This is in the axis for the security market line with the stock estimated expected return on the vertical axis and risk on the horizontal axis. Then the beta of after-tax debt we can get from, so this is what you guys got in store 3, the after-tax cost of debt, but then using the capital asset pricing model, you can get the beta of after-tax cost of debt. And then either you can do the weighted beta to find this, and that will then give you the WACC. Or what we did was I calculated the WACC first using the weighted average cost of capital calculation to get this. And then you can get beta assets using the capital asset pricing model. Every time you go up and across, it's using the capital asset pricing model. If you're going to go between on the same axis, that's using the weighted average, if that makes any sense. So think about it, study, study, study. Let me know if you have any questions. I can take questions. I don't know. If you really need something quick, you can take a picture, send it to me, ask me for advice if you're on the right track, because I agree, if you don't know what you're doing, the solutions are kind of confusing. So here's an example of how to do these things. And they're basically the same thing again and again. Okay? So I'll post this
Okay.
one.
Thanks. Have a
Bye,
nice
little.
day. Happy
Bye.
birthday.
Israel was quiet, but he's probably has no questions, right? You're okay?
I'm here.
You're okay? You got
I'm
you
just, I was just looking at the answers and comparing.
it's okay, right? It's I just did it kind of a roundabout way, but you see all the answers are there.
Yeah, and you answered some of my questions too. So
Good, good. Just keep going. It's always the same thing. It's just one more of the same types of problems. Nothing terribly new, but just to be confident, do them all.
yeah, thanks.
Okay,
Thanks.
bye.
Have a good day. Happy birthday.
Thank you. Bye.